Hello Math 152 students. In this video, we will take a look at 11.3 where we're looking at two samples and means, but the difference is we will have non-paired data or independent samples. So we will say to test hypotheses regarding two population means, mu1 and mu2, population 1 and 2, with unknown population standard deviations, we can use the following steps provided that we have these four conditions met. So the following steps on the next few slides are going to be our steps 1 through 5, the same exact steps we've seen in chapters 10 and 11 up to this point. The conditions are going to be what's different. The first condition, the samples are obtained using simple random sampling. We don't want to have a convenient sample. We don't want to have cherry-picked data. Point 2, the samples are independent. Another way to say this is the data is not paired. Sample 1 does not dictate who is in sample 2. Then, the third point, the sample sizes are large for both group 1 and group 2. We have to have bigger than 30 for each one, or I should say 30 or bigger for each one. Or for small data sets, less than 30, we need to check the QQ plots and box plots for each sample individually, meaning we'll have two QQ plots, two box plots. The only way we can get around this is if we know the underlying distribution is already normal, and that would just lead us to not checking QQ plots. But again, most of the time we will be in the large scenario or needing to check two QQ plots and two box plots. Then the last one, for each sample, the sample size is no more than 5% of the population. Most of the time, this is not going to be an issue because we're not going to have such a large sample that we're getting close to our population size. So if these check, mainly we'll be focused on number 3, then we can do our setup and proceed. Just like our previous hypothesis test, we can have two-tailed, left-tailed, or right-tailed. The big contrast with 11.2 is that instead of having mu sub d, the mean of the differences, we have mu1 and mu2. So in every case with the null hypothesis, we start off by assuming there's no difference between the two data sets. Then, depending on the researcher's claim, we could either say there's a difference, they're not equal, mean 1 is less than mean 2, mean 1 is greater than mean 2. Step 2, make sure we've specified our level of significance. Compute the test statistic and p-value using StatCrunch. Just as our other scenarios, if your p-value is less than your alpha, reject the null, and if we reject the null, we accept the alternative. And step 5, state our conclusion in everyday language. Just like before, the procedures are robust, which means that minor departures from normality will not adversely affect the results. Meaning if you have a little bit off with your QQ plots, that won't cause huge problems. However, if the data have outliers, the procedure should not be used. So like we saw in our first 11.2 example, that evidence of an outlier caused a problem there. We're going to see the same thing here. The big difference is we're going to have two box plots and both have to look good. So no outliers in either group. So back to one of our previous examples, we discussed the quarter case with the state and traditional quarters. So a researcher wanted to know whether state quarters had a weight that is more than traditional quarters. He randomly selected 18 state quarters and 16 traditional quarters, weighed each of them, and obtained the following data. So notice we have less than 30 data points in each sample, and we are not paired. In fact, we can't be paired with our differing sample sizes. So we have our sample, and let's go ahead and take a look at this in StatCrunch. So notice we have two columns of data, and we need to create our QQ plot for each one and our box plot for each one. If you select both columns at the same time, StatCrunch will create two QQ plots. Save you a little bit of time. Notice you just have to scroll over to see both. And I would say they look approximately linear. No big issues here. Then for our box plots, again, select both. This will create a side-by-side box plot, two box plots on one. Check your fences and we'll draw our boxes horizontally and compute. And this is insightful as well because it shows us that the box plot for the state quarters is higher up, meaning those weights are higher, which sometimes helps you set up your null and alternative if you're having trouble picking it out from the way the problem is worded before you look at the data. So no outliers on either one, we are good to go. So let's go back to our slides and take a look at our setup. Okay. So we checked our conditions, we have our setup, and notice we can state this as test the claim that the state quarters have a mean weight that is more than traditional quarters. Okay, we already saw this picture. Here they just use a slightly different software. And for our setup, we want to make sure we write out our null and alternative. Our null always has the equals, so if nothing is different between the two groups, our mean 1 equals mean 2. Our alternative, that these state quarters are heavier, our state quarters were our group 1, our traditional quarters were our group 2. If we forget which one we specified, we can always look back. So state is group 1, traditional is group 2, and then make sure you're not mixing these up when you look at the box plot. The state, this is group 1, this is group 2. So we're saying mean 1 is greater than mean 2 if the state quarters are bigger, or heavier, I should say. We know our level of significance, and we're ready to go to StatCrunch and find our test statistic and p-value. So we'll close this down. And we want to go to our t-stats, to sample. Sorry, mine was having some issues there. To sample with data. Select our two columns. Now, there is an option here that asks you if you want to pool your variances, and the default is to turn it off, and you do not want to check this option unless they tell you something that says assume the variances are equal. So you do not need to change this. We'll leave that the same. And then notice the setup is slightly different than our null and alternative. They went ahead and subtracted mu1 minus mu2. So saying that they're equal is the same thing as having a difference of 0. So we can leave this alone. And then in our situation, we said mu1 is greater than mu2. If we subtracted mu2 over, this would say mu1 minus mu2 is greater than 0. So again here, don't be tripped up by the zeros. They're just slightly formatting this differently. And right now, let's not create any graphs and go ahead and hit compute. Notice my p-value is very, very small. It is smaller than 0.05. Or we could say this is approximately 0.01, or if we wanted to go to 4 decimal places, write out the whole thing. And I just want to show you one other option with StatCrunch. StatCrunch has the ability to create those QQ plots and box plots for you, kind of like our previous examples. So I'm going to select my columns again, choose my greater than, and then if I wanted to do my box plots and QQ plots, select those two. Two box plots and the two separate QQ plots. So again, it's often helpful in setting up your null and alternative and writing them down to go ahead and check your box plots first, and you might as well go ahead and check your QQ plots. If you do it all in one step, just don't forget to check for your outliers because that can put a halt to your analysis. So let's go back to our slides and finish this one up. With our very small p-value here rounded to 2 places, we reject the null, and anytime we reject the null, we accept the alternative. So the way we could say this is, since the p-value is less than the level of significance, we reject the null and we accept the alternative. So let's not stop there, finish it up in everyday language, and we would say there is sufficient evidence at the alpha equals 0.05 level to conclude that the state quarters weigh more than the traditional quarters. So the last thing I want to show you is just a quick contrast on the with summary option. If we go to our ebook in section 11.3, this is on page 499, examples like number 9, we have a summary. So this one is looking at how fast people walk in the airport, whether they're getting on the plane or getting off. And they ended up doing 2 samples. Notice the sample size is 35 in each case. And they reported the mean and the standard deviation for departure and for arrival. So in this case, we don't have our 35 data values for each one, but we do have the summary. This is not a problem in StatCrunch. Another page pulled up here. But if you go into your StatCrunch, into your T-Stats, you do have a 2 sample with summary. And for the summary, they will ask you for those 3 pieces: mean, standard deviation, and sample size. Again, if you have your summary, you still want to leave this box unchecked, and everything else is the same. If you have the summary, you don't have the option of checking your QQ plot and your box plot because StatCrunch wouldn't have that information to create those. So your optional graphs are quite a bit different. All right, so that'll wrap us up for our examples in 11.3. Make sure you let me know what questions you have.